Oh, I don't see anybody there waiting for us. Let's check. To check. Not too bad. The attendance is one of those small data issues that we as CIS people don't think about. They pulled it into Canvas, so that's great, but you have to either have multiple tabs open and risk overwriting it or something, because now it's all right there, so I can't have it in a separate window like I used to be able to. Complain. You know how those little things are, they fix it. We are done with lesson 2. We were having a great time looking at all of these data modeling concepts. When we were looking at the lesson 2 stuff on Cengage, first of all, they asked us some things that weren't actually presented in the chapter. So we did create a little video last week after our class to kind of explain those things, but it is in this chapter.
For the assignments, did you mean for you do it at midnight?
These ones, are they still at noon? So I'll get those fixed for midnight. I should just leave it at noon since that's the default, but it drives me crazy, so I'll make it midnight. I know I got the ones for next week midnight. So I'll fix those, so don't worry about it. Yell at me if they lock you out. But I should be able to get it before noon. Get all those fixed so you'll have the rest of the day. We do have a lot of them. For our module 3, I was a little more selective in eliminating some of those, so you won't have quite so much practice creating data models. I know that it's good for you to practice, so I hope everybody went through them, relatively quickly. Let's see. You mentioned that I would try to get our vocab on Quizlet, and I was able to find some, so we do have a few out there on Quizlet. I've updated some links in Canvas for you. To start the morning, I thought it would be good if we tried a Quizlet live, get you guys woke up. We're gonna try individuals so that we don't have to invade each other's space. If you've ever played Quizlet Live before, you have to have your phones or devices right kind of next to each other, and so it could be a little close. So we're going to try individuals. And I have a couple of options on how the questions are formatted. I'm going to choose this option where Quizlet chooses like an answer and makes it the question. So anyways, let me know if it doesn't make sense and we can try the other option. Different vocab sets work better with different options. All right, so we're going to try this. Haven't done it before. Everybody, if we do have any people at home, they should be able to join in. Go to www.quizlet.live and enter this code. We've never really played Quizlet Live before with everybody on computers because it was always something that was more phone oriented, so we'll see how it works. Being real quiet. Why do I not have music? You shouldn't have to.
I didn't have to.
Just make sure you go to this Quizlet.live, not Quizlet.com. Make sure you put it in. What do you think it's turning on? Not getting any sound. I'll figure it out eventually. All right, getting some sound out of that. Okay, we have 13. A couple more. We'll see what it's like. Okay, I'm gonna go for it. Let's try it. Okay, everybody has their own team. I heard that sound. Let me turn it down before it deafens us all. Got it working. Okay, let's start it. Ooh, big leaderboard. What's it doing? I can't tell. I'm gonna have to come look. Are sea turtles, is somebody having trouble?
Yeah, what's the code?
Oh, 550-985. See if you can reconnect. Does it put you back in your account?
It does, it gives you a choice, you need to go out and different.
We'll see if the people. Did it let you back in, Jacob? Is it doing really wacky? Are you guys killing it? Should we try our phone?
I'm on my phone right now. It's not having a great time.
It's not helping either, huh? It's just laggy.
Well, I got disconnected. Now
Did you? You guys broke Quizlet? Is that fast? Well, how is Quizlet doing this Tuesday morning? Not so well, huh? Who's our panda? Let's see if they can win. Oh, yeah. Get on again? Oh, come on, you guys have a chance to catch it. It's probably dead all the way. Got that music to work. Yeah. Yeah, now that the music's working, it just quit doing anything else, huh? But I do like this music better. Does it let you join it all? Yeah, I started again. I didn't mean to, but it sort of whacked out. I think it decided that it would start again. Fun with technology. Six, come on. Is it letting you in? You. Test out these network systems. Our job as database analysts to test out the network.
We're DDoSing.
Start letting a couple people in. Should I go for it? I'm gonna go for it. Moving some people out.
How did we actually get the same animal again?
We have a few less. Our leaderboard fits on one screen now. We'll see if it can stay alive. We have no sea turtles this time. I was watching those sea turtles to see how they did. That looks better. We just had to leave some people out. Owls just got shot down. We got some competition here. Oh, that must have been a bad one. Yeah, strong lead. Really strong now. That last hard question. Still waiting. Seems like so many questions when you're on your own. Kind of a race for second and third here. Catch up with that T-Rex. Be very careful. They know they have time. Ah, Mary took it, yeah. Give a hand, yay. Fighting through all of our technical difficulties. So get out of that. So anyways, if you go to the links on Canvas that say vocab, I added the word Quizlet to our lesson 2, but then in lesson 3, it's just Quizlet, because you can get to that other vocab through the Mindtap stuff. So I figured you could find it without a link. Speaking of which, let's go find all that stuff. I'm going to go up to this main link and do the Mindtap home. As an instructor, it's always a hard decision what Mindtap stuff to bury into Canvas and what to not. So one thing that I just opened up is this in the news link. Let's take a look. You should be able to bring up this in the news e-week subscription. So lots of interesting things are in the news. We looked up that new NVIDIA card last week, and what was it, like $12.95? More than the computer. And then there's a nice article about security. A lot of people in here are interested in that. Networking updates, cloud computing companies. Some more security information that's very interesting. Russia attacking Tesla. So lots of things that we don't even think about from a security standpoint. Very interesting stuff. So I've opened that up for you if you're just, you know, waiting for an appointment or something and just want to read some interesting updates. That's a great subscription. So we were done with lesson 2. We're finishing up with it. Everybody's creating their multitudes of model diagrams. Let's open OneNote and get our notes going. And I want to start a new tab for chapter 3. And of course, when you're in here early and you're waiting, you know, you want to review those earlier tabs and see if there's stuff that you want to add in. More pictures, more items. And then I'm going to pull that PowerPoint presentation in. So I already have it downloaded. Let's see if I can find the download link or. Find it in my download folder. And my folder's all messed up. I'll go grab it again. So let's see, I'm looking at lesson 3. I want this PowerPoint. Get it saved. And then I'm gonna drag it and drop it into my OneNote. It's a printout. And I'll show it to you as soon as I can drag it over. So our textbook, I've mentioned it about a billion times probably, is new. Other things content is new. So we did see a little bit of a glitch with our last chapter where they were asking us some questions in the problems, but they hadn't really covered in the material. So if you felt that way, you were right on. There was some material. And so that's what that little short video was that I sent out Thursday afternoon, just explaining that. But we should get a better explanation in this chapter where that material is covered. And I think that's pretty simple for Cengage to move those questions. I've just got to make sure to get that information to them. So what are we looking at in this chapter that we're going to find out more about those questions? We saw so much in our last module about different models and different diagrams and different ways to explain data visually, right? Because if I sell things, I sell products, I sell those products to customers, I'm going to have that kind of relationship with entities for my company that I'm going to need to be able to describe. And so those models give me the opportunity to do that in a visual way that's really understandable by everybody. So we want to go a little bit further and look at some of the logical structure behind the model. And we saw last time that the attributes of an entity are listed on that diagram. We want to get a little further into that discussion. How do we decide, what data belongs with which entity, and what other kinds of things do we need to do in making those decisions? We're going to do some interesting sort of data math using database operators to manipulate data sets and look at the purpose of the data dictionary and system catalog. These are the places where all of our entities are defined. The definitions are stored. We want to look at some entities and relationships among entities in just any relational database model. We're going to get to those one-to-one, many-to-many, one-to-many relationships again. And look at data redundancy. We saw already from the very beginning in those little spreadsheet views that they showed us, if we have Mary's name 17 times in all of these different table rows, that data redundancy is going to lead to problems as we work with our data. So we're going to look at when we have to have some sort of redundancy and how we can eliminate redundancy that's unnecessary. And then as we're building a database and creating our tables and entities, we'll talk about how in the physical database, indexing our data can help in retrieval. So our models are just a logical view. We have this database that's physically stored out on disk somewhere. And when we look at that entity relationship diagram or whatever other relational diagram, we're just looking at a logical representation of that physical data. What's it look like? Some sort of view. They have some videos for us. Let's take a look. The one I want to check on is real short. Let's just see how good they are. So in module 3 under visualize, I'm going to bring up this one that is relational database tables and their characteristics. And normally, of course, I would have you watch it at home, but let's watch it together and kind of see what they've got to offer us.
We'll take a brief look at relational database tables and their characteristics. Logical view of the relational database is facilitated by the creation of data relationships based on a logical construct known as a relation. Because a relation is a mathematical construct, most users find it much easier to think of a relation as a table. A A sample table representation that will be used to illustrate relational table characteristics is shown here. You'll discover that once you understand the requirements of a relational table, it is possible to spot and define some entity relationships using a table view of the data. Relational tables are two-dimensional, meaning that they are composed of rows and columns. Each table row, also called a tuple, represents a single entity occurrence within the entity set. For example, student number 324273 is a single entity and has many attributes associated with it, such as first name, date of birth, and GPA. Each student is represented by a single row, and each row contains data on a single student. Each table column represents an attribute, and each column has a distinct name. In this example, the 7th column represents the student classification for each student and is named Stu Class. No other column in the table can have that exact same column name. Each intersection of a row and column represents a single data value. For example, this student's classification is SR, or senior. All values in the column must conform to the same data format. For example, all attributes in the student date of birth column are dates. Each column has a specific range of values known as the attribute domain. For example, all attributes in the student GPA column are numbers between 0 and 4 with 2 decimal places. The order of the rows and columns is immaterial to the DBMS. Each table must have an attribute or combination of attributes that uniquely identifies each row. In this example, the attribute student number uniquely identifies each row because all values are unique. That is, there are no duplicated values. It is important to understand that a table is actually a logical concept rather than a physical construct. The data is not physically stored in this format. One of the great advances of the relational model, however, is that we do not have to work with the data as it is physically stored. We only interact with the data as if it were in a table structure. Be aware that many database software vendors still refer to table rows as records and table columns as fields because this terminology is familiar in most programming environments. This concludes our presentation.
Woohoo, okay. Very good. And then I have a different one. This guy, see if I can bring this one up.
Hello, I'm going to talk to you about databases. My name is database manager.
Can you hear him?
I'm the person who knows where everything is and how to get it. I've organized my database in lots of tables. I've got a table for the form tutor, I've got a table for the form group, and I've got a table for the students. Each of these tables contains lots of records. So what exactly are all these records doing here on the student table? Hi, Joe.
Hi, Mr. DBMS.
Well, a record is all the data we want to store on an object.
Hey, who are you calling an object?
Oh, ignore him. In a database model, an object is something we want to record information about. In this case, it might be the student's name, their date of birth, what form they're in, and their student ID number. I can then come along and interrogate the database. Hands up all those in the tutor group 7DF. Each student gets their own record. So here we've got Joe, you've already met, Fred, Francis, Bill, and Bobby, each with a separate record. If a new student arrived, we'd have to create a new record for them. Let me show you around inside Joe's record. We keep 4 bits of data about every student in this database, and to keep everything organized and easy to find, I keep each one in its own separate field, as you can see here. 4 pieces of data, 4 fields. The first field is the student ID number. Joe's number is 13421. The next field stores Joe's form, and we keep Joe's name in this name field. Finally, his date of birth is kept in the DOB field. Hang on a minute, There's someone at the gate to that field. Hey, who are you?
I'm the data type police, and it's my job to stop users messing up the database by entering dirty data. You try putting something in this field that isn't a data,
Scary, isn't he?
and I'll stop you.
So what if I tried to put the word red in here?
Is red a date?
No.
Then it ain't coming in.
Oh, well, how about if I try putting a cow in this field?
Is a cow a date?
No.
Then it ain't coming in. If it's not a date, it doesn't get in.
Well, good. Actually, I like this policeman. He stops people messing up my nice clean data. And if something goes wrong in a database, it's because somebody has put something wrong into it. So, in a record, we have fields, a field for each piece of data that we want to store, and we can set data types for those fields to help make sure the users can't mess it up.
Okay, so 3D animation guy. Let me get out of this one. As you can see,
I'm the database manager.
there are lots of different usage of different terms, but we saw that the Cengage video said those terms were older record field, still really, really important. So that can be one of the hardest things that we're working with here, is a bunch of different terminology that kind of describes the same thing. And of course, there's minor differences, minor nuances in those definitions. So we just really have to be term aware in our class. And that's why it was important to me to get those Quizlet vocab terms set up for you and things, because our terminology is a lot of what we do, and it defines kind of, you know, what we're trying to explain to others. So we've got to get those terms down.
Ms. Riley, you're not sharing your screen on Zoom.
Oh, thank you, sir. Let's do that. Is that better?
Yep.
Thank you. I've got something not set right where I'm not seeing it. Oh, we'll work on it. So whenever we're looking at, they said, all of the companies in the country that sell things are going to have customers, right? They might refer to them as partners or some other sort of terminology, but we all have these same basic entities when we have a given function for our company. But yet, we can still see many, many different database designs for those same entities. And that's a good thing, because that gives us the creativity to set things up the way our company needs them. But no matter what we do, we want to make sure that we try to stay as simple as possible. So we're not complicating the world and trying to make things even more difficult for others. Okay, so we've seen a lot about these relationships where we're saying that, you know, an order has to have products that were ordered and a customer that did the ordering. So those relationships exist in the real world, and we have to emulate them in our database definition. Here's some nice definitions for us. Characteristics of a relational table. First of all, a table is perceived as a two-dimensional structure of rows and columns. So notice that's just our perception. That's how this table has been represented to us and visualized to us. It's actually disparate data saved out on a disk drive that's brought together for our view to give us that perception. Now, each table row or tuple represents a single entity. Each column represents an attribute, and each column has a distinct name. Each intersection of a row and column represents a single data value. All values in a column must conform to the same data format. So for number 5, we're talking about, you know, the field police. If it's a date, then all of the data in that column must be a date. We can't just have this Joe Smith column where our users say, no, I just really need you to type something in there different, like Joe's going to become active on 10/1. No, we only take a date. So that's its attribute domain. What is the domain of acceptable values? The order of the rows and columns, how we put things on our table, doesn't matter. That only kind of matters to us. We like seeing the most important columns first, getting to the least important, but that doesn't matter. It's totally just however we want it. And each table, they say must have, it's just really highly recommended that we have an attribute or combination of attributes that uniquely identifies each row. So if I'm looking at a student table, I'm going to assign a unique student ID to every student. And that's going to be my unique data element that uniquely identifies each row. Whenever we're looking at that unique data element, that's going to be considered a key. So a key could be any sort of attribute that defines something. If I'm looking at a student, their last name could be a very important key field depending on what I'm doing, but it's not necessarily unique to that student, right? But it's still an important key field. So there's a difference there. We can have keys that are not unique, but we still need that unique key to identify each row. We can use our keys then to establish relationships among the tables. That unique key is usually called our primary key. So our primary key is the one that uniquely identifies this individual row, this individual student. Now they have another video that is keys. Let's see what they say. I'm everywhere here, sorry. Visualize. Let's see what they say.
In this video, we'll take a brief look at primary keys and foreign keys. A primary key is an attribute or combination of attributes that uniquely identifies any given row in a table. For example, in the student below, student number is the primary key. Note that a student's last name, L name, would not be a good primary key because several students have the last name Smith. Even the combination of last name and first name, student F name, would not be a good primary key because more than one student is named John Smith. Formally, there are two important requirements for the primary key. First, all primary key values must be unique. Second, no part of the primary key may be null. A foreign key is the primary key of one table that has been placed into another table to create a common attribute. Unlike primary keys, foreign.
What is null? No value. So if we're saying that something is a primary key, it has to have a value for us to create a row.
Keys may contain duplicate values and may contain nulls. In this figure, the primary key of vendor, VIN code, was placed in the product table. Therefore, VIN code is a foreign key in product. One advantage of using a proper naming convention for table attributes is that you can identify foreign keys more easily. For example, because the student table shown here used a proper naming convention, you can identify two foreign keys in the table, department code and profnum, that imply the existence of two other tables in the database, department and professor, related to student. This concludes our presentation.
Okay, and then the other video. Now this David Fountain guy keeps messing with his video, so I hope this is the right one. We shall see.
Hi, I'm the Database Management System, DBMS to my friends, and I'd like to explain to you why you should use keys in your databases. Before I explain what the keys on this class table can do, let us look at why we need keys in the first place, by having a look at some records in the students table. Hi guys.
Hi, Mr. DBMS.
Let me just check that everyone's here. Max?
Yes, Mr. DBMS.
Joe?
Yes, Mr. DBMS.
And that's our problem. I cannot tell which Joe is which just by using his name. I need something that is guaranteed to be unique. And with millions of students around the world, I just cannot use everyday information such as their names to be certain I've got the right student. I need to find something that will be different for each and every student. Sometimes there will be a unique field, but for now, I'm going to give each student an ID number. This is something I can control and therefore can guarantee to be unique. This is the secret to making sure I don't mix up one student with another, and it's going to be my primary key. If I know the primary key for this table, I can be absolutely certain I have the right record. Each student gets a different key value. As you can see here, only the right key value will let me get at the right student's record. Keys are useful because they stop me mixing up one student with another, but they get even better when we use them in other tables. Let's have a look at the classes table. Does that look like 2 copies of Joe's key on those 2 records? Yes, they are. And because I know they are student keys, I can use them to go back to the student table and look up anything about Joe that I might need. These copies can appear in many records on this table. When a key is used like this, not in its own table, it is called a foreign key. I like to think it has travelled far from its own home, is on holiday. In this class table, can you see that Joe, with the pink key, is taking 2 classes? Now what about those other keys? They are different from the student ones, and that's because they are keys for the teachers. If you want to find out more about those teachers, we need to look for those key values on the teachers table. So which teacher has the yellow key? Who has the yellow key?
I do. I'm Mr. Smith. I'm a science teacher. I've taught here since September 2006. I'm married with...
Thank you. That's quite enough information for the moment.
You know how teachers are.
And once we know the key value, we can use it to get all the information we need to from the table where it is the primary key. Putting this key value into other tables as a foreign key means we can keep all the information about Mr. Smith in one place and then just use the key to look it up when we need it. So to summarize, a primary key is a unique value in its own table. If the key is then used in other tables, it's called a foreign key.
His finger just went through that table, did you see? Very good. So I like the way Mr. Fountain explains those key relationships in his 3D-ness. So we can uniquely identify a row. So in your OneNote document here, let's see where we are. On this keys slide, if there's anything that you want to add in there, while it's kind of clear in your head, do so. I'll put this on the Zoom session for you if you want to do a snip or something of this video. So Mr. Fountain, David Fountain here, was just working on preparing to teach his 3D animation class and working on his teaching his database class, and I like the way he combined the two. So he came out with some cute stuff. So our primary key is super important, super important. Way back, I remember when I first started teaching, and the business teacher was teaching Access, how to use Access database, and students were asking me questions about it, and she did a great job. She always did a really awesome job. But they never used a key. They never once set a primary key for any table. It wasn't in the book. It didn't say that you need to. She didn't have any sort of background, so she didn't know that it was important. Super important. I mean, when we're using a small little Access database, it's not the end of the world. But if I start looking through millions and millions of rows trying to find a specific order or something like that, then that primary key becomes very, very critical. Get to the right order, get to the right customer, or whatever it is that I'm wanting to find. So we have a couple of other terms here Let me jump around someplace else before I get back to this. This is the textbook. So not much different than the online version. And the thing I wanted to bring up were these definitions over here, because they have a whole bunch of them in our book. And they're kind of just hidden in little different areas. But we saw that a foreign key is unique across a table. When we're using that foreign key, or I'm sorry, a primary key, when we're using that primary key in another table, it becomes a foreign key. When we're working with foreign keys, we get concerned about referential integrity. If I have a new employee, and in my employee table, I have a foreign key for department number. When I get that new employee, do I have to know what their department is before I can ever add them to the table? Or can I set them up with it blank and then come back and decide later what department they're in? Not a big deal to us, right? But a big deal to the human resources department, depending on how things are set up. That is a decision that impacts referential integrity. If I say that that department number has to be assigned when I create that employee, I'm going to say that there is a referential integrity rule set up in that relationship that says I can't have an employee without a department. If I decide that I can leave that blank, then I've decided I don't need to enforce referential integrity between those two tables. There is a relationship, yes, but it's not enforced. Does that make sense? Now, I still am going to make sure that if I try to put data into that column, it has to be a valid department number. The database management system will continue to make sure that field is valid in that way, that that data does exist. So besides our key fields, we mentioned we could have other data types that are important to us, like the last name. Those would be secondary keys, things that are important to us, but we wouldn't be able to use them to retrieve a specific row of our data. Because with, like we've seen with last name, we could get 7 rows back if we choose to see all of the employees whose last name is Smith. We need those secondary keys though, and we need to know that they're in the database, because our business function might involve people calling in and they might not know, like in their example here, they might not know what their customer number is, but they know the name of their company. So we have to have those secondary keys to look things up like that, to even find that primary key, because sometimes our primary key is just a meaningless bunch of numbers. To be unique. Okay, so some other terms. Is the more you get into the computer field, the more you'll realize that sometimes the big difference between products is just the terminology. And some companies like to come out with a new product that's different from the other product, and really the only thing that's different is what they call the thing. And we have to deal with it, because now we have the same term that means all these different things, or many different terms that mean one thing. So a super key is another term for a primary key. So a super key is an attribute or combination of attributes that uniquely identifies each row. A candidate key is, let's read this definition here, a minimal, irreducible super key. So it's a super key that does not contain a subset of attributes that is itself a super key. So what are they saying there? They're saying like customer number is a super key, it's a unique key, it's a primary key. It's also a candidate key, because it's not made up of other things, right? So if I used a phone number as my primary key, that would not be a candidate key because it could be made up of the area code and the rest of the number. So since it's two pieces of data put together, it is a subset of attributes, so it can't be considered a candidate key. So just a really small difference to make it a little bit different term. And that's important when we're designing databases, all of these things. Now, a primary key is a candidate key selected to uniquely identify all other attribute values in a given row. A foreign key is an attribute in one table whose value must match the primary key in another table or be null. And finally, a secondary key is that name or whatever other data items we want to use to be able to get to data. So when I was thinking about this morning or last night, I was thinking, what's some really big database things that are going on right now for us? Well, the census, right? That's a pretty big database that we create every 10 years in our country. So what would be a good candidate key? What would be the ultimate key for the census? Think about it. What do they use? Seems like they use address, don't they? Because if they haven't heard back from an address, they send someone out. So just think about that. How would you set up that data relationship? It only happens once every 10 years. They probably get to redesign each time how they're going to question. We know that the questions are different. So how would you save that data? Be thinking about it and all the different keys that are available and how you would use those. So I don't think there's a right answer. It's just something to really ponder and think about. So I have all these rules that have to do with keys. And we mentioned referential integrity is being the integrity that says my reference to another is good. I have a good reference. I know how to access that other data. So we can have some other integrity rules besides that reference integrity, my reference to another area. Some other things that we can do, let's take a look at these within an entity itself. So within all of our students, we want to make sure that we have integrity. And that means all of our keys are unique. We don't have any key parts that are null. Why we need this integrity? So that each row will have a unique key that we can locate. And their example here is we can never have a duplicate invoice number. How would we know what bill we sent out if we had duplicates? And then referential integrity is that integrity where our reference to another row in another table. So we can say a foreign key can either have a null entry or an entry that refers to a mapping primary key. So their example, like our department example with an employee, is that we might have a customer that doesn't know who their sales rep is yet. When we do assign a sales rep, it better be a valid sales rep, but not having one assigned is okay also. And that's a decision we make when we design the database based on our business rules. There's our picture there. So we have entity integrity within our customer table because we don't have any duplicate keys. And then we have referential integrity where our customer table has an agent code that refers to an agent in the table or is empty. So in this case, we have entity integrity and referential integrity. Now, what's this one? This is an interesting concept. They say that sometimes we don't want to deny that referential integrity. We want to go ahead and say there cannot be a customer without an agent in the table. But we'll set up like a dummy agent, like a dummy row out there in our agent table. And so if we don't know who the actual agent is, we'll use this dummy variable as our agent code until that gets assigned. And then we could run a list of all customers that are assigned this agent code -99, and we'd know which customers need to have agent numbers assigned. So this is a cleaner way of doing it, where we are putting that referential integrity rule in our database, saying no customer can be created unless they have an agent code. But then we're saying, but if the agent code hasn't been assigned yet, use this -99. This will be our dummy code. Does that make sense? So that's something that we do all the time. And that's a thing that would have to be a business rule, right? That needs to be written out in our rules, because if we don't keep track of that information, it could easily get lost between the design and the development process of our application. Okay, so relational algebra. That's what we're really working with here with our database. We have, each of our tables is a set of data. So when I look at my student table, all of the rows within my student table are my set of student data. So I could have, you know, specific rules about that data, whatever I'm working with, but all of the set theory that comes with relational algebra, which is a great math area, is going to apply to that set. So let's get some definitions down. Relational algebra is just a theoretical way of manipulating table contents. So it's because we're working with tables and relations, and we sometimes even can see that those terms can be used interchangeably, we have a special type of variable called a rel-var, and it's a variable that holds a relation. So they give you an example and they say, if you're writing a program, you might use a variable named qty for holding an integer data. The variable qty is not an integer itself, it's just a container for holding integers. It's just a spot in memory. Similarly, when you create a table, the table structure holds the table data. That structure is properly called a rel-var, and the data in the structure would be a relation. So that rel-var, that variable, is a container for holding all of the relation data of the table. So when we look at a variable like that, we're going to have two parts, the heading and the body. The heading contains the name of all the attributes, like all of our column names, and then the body contains the actual data. To maintain the distinction in formulas, we will use some specific terminology, a lowercase r, an uppercase r, to signify these relations in our relational algebra. So we're really at a good stopping point here. So we're at 3-4b, talking about relational set operators. Read through this material before next time so that we can talk about it and we can look at some different visuals of the different relationships and kind of get an idea of what's going on. Now this content here, these concepts, help reinforce the problems and things that you'll do in the Mindtap utility thing, but it's also a little bit separate because this is going to give you more of a background of how those things work and how they happen. So I'll get those assignments updated to be midnight tonight. I know some of you are still working on those. The new ones for this week, if I can find that area. There are 2, again, of the critical thinking things. And then in the problems, when you first click on it, it tells you which ones to skip. And then when you do the click on this load thing, it goes ahead and loads. So make sure you're paying attention to that screen that tells you you have to click again to load the things. So some of them I left in where it wanted the ERD diagram. Some of them I left in where it wanted the relationship diagram. Hopefully I picked the right ones for the future as we move forward. So that should make it a little bit less. Most of the other things in the problems were fairly quick. They don't have a huge quantity of diagrams like last time. Let me start it to show you. So like this first one, for each table, identify the primary key and foreign key. So the question itself looks really big because it's got all this data for you, but it's actually a really small, manageable question. So you should find most of them to be that way this time. So yell if there's a problem. Any questions before we break for our lab to work on that stuff? Don't forget to keep your study group in mind, asking them what they think about things and kind of sharing notes with each other until we get to some assignments where you're really going to depend on them. But I'm out unless you have any questions. Let me know if your Discord group is not set up properly or something. You should be seeing your group. You should have a voice chat and a text chat with them.